Hello. So good morning. So good afternoon to all of you. So fine. In last class, we have discussed regarding the cement and how the of cement we already have discussed. There is two composition of cement. One is argillaceous, second one is calcareous one. Argillaceous was in lime, this clay, slate, laterite type of materials, and calcareous is lime when we mixed in a certain proportion. And we already discussed the constituent of the cement. What are the constituent of the cement? Lime 60 to 65%, silica 17 to 25%, alumina 3 to 8%, gypsum 3 to 4%, iron oxide 3 to 4%, magnesia that is 1 to 3%, and sulfur that will present 1 to 3%, and last the alkali should not be more than 1%. These are the various constituent of the cement we already have discussed in last class. So next we will discuss the function of the different constituent. What are the different constituent role in the cement? Lime generally it provides the strength and soundness to the cement, and silica imparts the strength to the cement. But in excess amount if you put, then it will increase the setting time of the cement. Alumina generally it is provide the quick setting property to the cement, and generally it reduces the clinkering temperature if excess amount of alumina will present in the cement. Next we discussed about the gypsum. Gypsum generally it is act as a retarder in cement. It will increase the setting time of the cement gypsum. So it is generally present in the form of calcium sulfate, and generally it is used to increase the initial setting time of the cement. And fifth constituent we already have discussed, that is iron oxide, that is generally present 3 to 4%. And then the iron oxide job is to impart the color. The color which you are seeing, that reddish brown color of the cement, that color is because of the iron oxide which is present inside the cement. Then we sixth constituent we discussed, that is magnesia. Magnesia generally it is also provide the color and strength to the cement, but excess amount of magnesia if you put in the cement, that will cement will become unsound, mean there will be disintegration of the cement will occur, or there is volume expansion of the cement will occur. The seventh constituent we already discussed, that is sulfur, that should be present 1 to 3% inside the cement. It is also impart the soundness to the cement, but the soundness due to the sulfur we cannot measure because there is no particular test available, laboratory test is available to measure the soundness due to the sulfur. But the soundness due to the magnesia and lime, that can we can measure, but soundness due to sulfur we cannot measure. There is no direct test are available to measure the soundness due to the sulfur. The last constituent, that is alkali, last but not the least, that is generally present in between the 0.2 to 1%, that should not be more than 1%. And the presence of alkali in the cement, that causes efflorescence. Efflorescence means the structure, there will be some staining of the structure will occur. It means there you see in the figure, there is some white gray kind of thing will be, white gray kind of spot will be formed in the structure. That is only because of the alkali present inside the cement. Then we discussed about the box compound. When you add water to the cement, then some chemical reaction will be start inside the cement, and because of the chemical reaction, some heat will be evolved, that is called heat of hydration, and because of this chemical reaction, some of the complex compound will simultaneously, not simultaneously, one after another it will form. The first compound it will form, that is called tricalcium aluminate. Second one, tetracalcium aluminoferrate. Third one is tricalcium silicate, and last one is called dicalcium silicate. So these are the box compound which is formed due to the uh, when you add water to the cement, there will be some chemical reaction will be happened. And what are the role of the box compound? I already discussed. Tricalcium aluminate, generally it is represented by C3A. Generally it is present 4 to 14% by weight, and it is formed within 24 hours. When you add water, after 24 hours, this tricalcium aluminate will form, and this tricalcium aluminate is responsible maximum heat of hydration. Okay, that is responsible for maximum heat of hydration. Then we discuss tetracalcium aluminoferrate, that is generally it is present 10 to 18% by total weight of the cement, and it is formed within 24 hours of addition of water. It is also formed within 24 hours of addition of water to the cement, but the amount of heat of hydration evolved during the formation of this compound initially comparatively more. But overall heat of hydration, if you say, then the tricalcium aluminate will responsible for maximum heat of hydration. But initial the rate of heat of hydration will be more because of the tetracalcium aluminoferrate, and which comparatively decrease the heat of hydration decreases with respect to prolonged time. With respect to time, the heat of hydration will decreases in the case of tetracalcium aluminoferrate. The third box compound, that is called tricalcium silicate. Please share this channel to all your friends and write your registration number in the chat box. So it will include your attendance in the class. So tricalcium silicate, that is C3S, represented by C3S, and that is generally it is the maximum percentage by weight is present inside the cement. That is 45 to 85% of the total weight of the cement is because of the tricalcium silicate, and it is formed within a 1 week. Within a 1 week, when you add water to the cement, and this tricalcium silicate is responsible for maximum early strength. It will early strength. Next, we discussed about the dicalcium silicate, and it is formed very slowly, and it will give the progressive strength to the cement at the later stage. So, if somebody will ask you which bogus compound is responsible for early strength of the cement, that is only because of the C3S. And which box compound is later on it will provide the strength to the cement, that is because of the C2S. Okay, early strength, in which practical field application is required. Early strength generally we required in a road work is required, and preferably some construction work, because construction work nowadays you can see they want to design it very rapidly. So there you want to gain the strength very rapidly. Then you have to use the cement which have the predominant constituent should be C3S, rapid hardening cement, and the low heat, that is C2S, is later stage. If you want to design any dam, so we don't want the strength to be gained very rapidly. It should be the progressive strength is required in case of the dam design, like barrage design, weir design. So there you can use C2S constituent cement, which has more C2S in the cement. So that is because low heat cement we can say. Okay, so that will see in the next class the type of the cement. And here hydration of cement we already discussed. So what is the total percentage of water required for total heat of hydration? That is 15% by water. 50% of water already stored in the voids, but the 20%, 23% by weight of 20%, 23% by weight of the cement. That percent of the water is actually required for the hydration process. So 23% plus 58, 15%, and 38% of the water by weight of cement is required to carry out complete hydration process. Complete hydration process. Then there is rate of hydration. If you ask, the rate of hydration of tricalcium aluminoferrate is greater than tricalcium aluminate, then tricalcium silicate, then dicalcium silicate. So early strength also you can write accordingly. So Then we discuss the manufacturing of cement. There is two processes are there, I told you. That is, one is dry method, second one is wet process. So dry method is a recent method, and wet process is a traditional method. In dry method we are not using any water during the manufacture of the cement, but in wet process we are adding water to make the cement slurry. Okay, after the formation of the cement slurry, we are allowing the cement slurry to pass through a very high temperature, 1300 degrees Celsius to 1500 degrees Celsius. So there the clinker will be formed. That can you see and get it better in this figure. So this is dry process, that clinker will form, and the clinker will finally it will grind through the tube mills, and cement seal or cement particle will form, and finally the cement particle is cooled down and packed, and then finally it will sent to the market for selling purpose. So this is the two method by which you can prepare the cement or manufacture the cement, dry method and wet process method, that you can discuss through this diagram. Then today we are going to discuss about the testing of the cement. What are the test? Different type of tests are there, or different type of tests are carried out to analyze the presence of desirable property in it. Desirable property means what should be strength, what should be setting time, what should be soundness. So all the property we can be analyzed by testing the cement. So the testing of cement can be done either in field, or we can do it in laboratory. So field test generally three types. Field tests are generally three types. So first we can do the field test of, we can do color test of the cement, physical property of this test. Physical property means physically you can sense, like see by seeing the, we can see the color, by touch, by finger we can feel the cement, whether it is rough or whether it is a fine kind of cement. Then field we can measure the strength of the cement by making a block of the cement, that we'll discuss in next slide. Similarly, laboratory test we can do fineness test, and then second one we can do standard consistency test. Consistency means the moisture content, what is the moisture content present inside the cement. Okay, that is because that we can measure by using standard consistency test. Then third one is called setting time. What is the initial setting time? What is the final setting time? And fourth one is called soundness test. Soundness means what is the volumetric expansion, because cement should not be allowed to go for the high volumetric expansion. So if it will happen, then crack will form, and finally the structure will collapse. Then in laboratory test also we measure the strength test. Then chemical composition test also is there for laboratory test. So next, the testing of the cement. Testing of the cement, first we are going for the field test. So in field test, testing of the cement, we are going for the field test. In field test, first you see color test. So color is very easy. Color test we can do, it is very easy to see. So the color test can be seen by a naked eye. The cements, when you are seeing with your naked eye, the color of the cement should possesses uniform gray color. Okay, suppose you are with the engineer, in site engineer, you will go to the field, and if you see the color of the cement gray color, then it is a good cement. So second type of field test is called physical property test. In physical property test, if you just take a pinch of cement in your finger and drop it between in your finger. If it is if you feel it is smooth, then it is a good cement. If it is feel where it is a rough kind of thing, then that is not a good cement. Means the cement should be as fine as possible. Second point, if you take some pinch of cement in your finger and if you put in a bucket of water, the cement should sink into the water, because cement specific gravity around 3.15. Okay, so it should not be float. It should not be float above the surface of the water. It should finally sink. Then that is called a good cement. And in if you take a bag of cement, in that bag of cement there should not be any lump kind of thing will be formed. Lump means once it will be like, and you can see like uh, a dense kind of thing will not form, because if some lump will be formed inside the bag of the cement, then we can say the cement already absorbs some moisture from the atmosphere, and already it has some heat will be liberated, and the reaction will be happened inside the cement, so that strength of the cement already decreases. So there should not be any lump will be present. Cement should finally sink into the water. When you touch the cement, you should feel the smooth cement. These are all the physical property test. Third test is called strength test, and the strength test generally done in field by preparing a block of cement. By preparing a block of cement, that block size you can see. If you see the side view, then that is 25 millimeter by 25, and length of this block should be 200 millimeter. So 200 millimeter, and if you see the side, this is the side view and this is the front view. If you see the front view, and the support should be placed at a part of 100 millimeter apart, and 340 newtons should be placed at the center of this support. So first what you have to do, prepare a block of cement to be tested by, let's say, 25 by 25 200 cubic millimeter. Then you should be immerse that block in water for 7 days. Now you remove this mold and you place a point load. What is the magnitude of the load? That is 340 Newton, and you place it over a support of 100 millimeter apart. You just place at the center of this support. And if this block will not fail, then we can say the cement has a good strength. In our job, our main objective, that when you apply the load onto this block, the block should not be fail. Okay, that is the sample should not show any sign of failure under the application of the point load. That is the thing. This is strength test. Then the lab tests are there. In lab test, the first test is called fineness test. Fineness test means you have to check the proper grinding. If the cement has more fine, means the cement has been gone through the proper grinding process. So if the cement has more fine means the specific surface area of the cement will be more, then the heat of hydration will be more. If the heat of hydration of the cement will be more, the rate of gain of strength of the cement will be more. So that's where checking the fineness test. Fineness test, generally it has been done by two process. First one is called sieve test, and second one is called air permeability test. Okay. So sieve test, we know you have to take 100 gram of the cement and you have to place the 100 gram of cement in an IS sieve. What is the sieve size? IS sieve number 9. So the opening size is 90 micron. 90 micron sieve size, you have to place 100 gram of the cement, and you have to perform this sieving process for 15 minutes. You have to perform this sieving process for 15 minutes. Then the weight of the residue which has been present on the sieve number 9, that should not be more than 10% of the original weight. Okay, so means if you take 100 gram of the cement, then 90% of the 90 gram of the cement should pass, only 10% should be retained, but it should not be more than 10%. That is the thing. Then second kind of test is called air permeability test. This air permeability test, air permeability test, that is actually represented in terms of the specific surface area that you are generally measure the fineness. Generally, you are measuring in terms of the specific surface area. So that is 1 centimeters means what is the specific area of the cement per mass of the cement. Okay, that is generally we are measuring the fineness of the cement. So this fineness test we are actually doing by using Blaine's air permeability apparatus. Blaine's air permeability apparatus, generally it is used to find out the to measure the fineness of the cement. So that is generally it is the best on the relationship in between. We have to flow some air through the cement bed, and the surface area of the cement particle forming the bed we are measuring. And that for ordinary Portland cement, the specific surface area should not be less than 2,250 centimeters square per gram. The specific surface area, it should not be less. It should be more than always 2,250 centimeters square per gram. Then that is called standard consistency test. Standard consistency test means, so standard consistency means, it means we have to know what is the minimum amount of the moisture content is present in this cement. Okay, So standard consistency should be known before we know about setting time. So when you are measuring the setting time, we are fine doing the test for the setting time or soundness test. So before that, you must do the standard consistency test. Okay. So standard consistency means what is the minimum amount of moisture content present inside the cement. Okay. So how to do this, perform the test? So we are actually performing this test by using a Vicat apparatus. That is called Vicat apparatus. At the right side figure, you can see this is a Vicat apparatus, which is a plunger. If you see, this is the plunger size is 10 millimeter diameter and 50 millimeter is the height of this plunger. And what you have to do, we have to prepare a sample. You have to prepare a sample, a block of the sample, and we have to prepare prepare a mold. In that mold, we have to take the sample, and what you have to do, we have to penetrate the Vicat plunger from a height of that is we have to release the Vicat plunger from certain height, and it should be fall gradually. And the needle you are seeing, the needle size is 1 millimeter square needle. The needle, it should show a penetration of 33 to 35 millimeter from top of the mold. Means what? Suppose you are taking a mold. In that mold, you are taking some amount of cement, 500 gram of cement you are taking. And what you are doing? First, you are gradually releasing this mold, this plunger. Then this plunger is entering into this mold, entering into the cement. When it will enter to a depth of 33 to 35 millimeter, then that water you record, how much water you have added. So that moisture content, when the plunger is entered or penetrated into the block of a depth of 33 to 35 millimeter, so that amount of moisture content at that time which present inside this cement is called as standard consistency of the cement. So we generally will find the water content at which the cement consistency is produced. Cement consistency is produced. Okay. So now what we have to do, we have to take 500 gram of the cement, and we are adding 23% by water, because already we have discussed 15% of the water already stored in the voids of the cement. So what is the additional amount of water we are adding? 23% of water we are adding at the first trial. Then what you have to do, lower the plunger gently up to the free surface of the mold, and we have to release quickly. Then the moisture content at which the cement paste of 100 constantly produced. The moisture content at which this needle penetrates the mold to a depth of 33 to 35 millimeter, that moisture content is reported as standard consistency of the cement. And that standard consistency of the cement is represented by capital P. Okay. So again, you are revising this one. So you can see in the right side, this is a Vicat apparatus. So we are preparing a cement. We are taking a mold. In this mold, we are taking a cement sample. Okay. Initially, we are adding 23% of the water. Then what we are doing? You are releasing this plunger gradually. Then quickly, we are releasing this one. So we have to measure the moisture content in this cement at which the plunger or the needle can penetrate into the sample to a depth of 33 to 35 mm from the top of the mold, that you have to do. So that at that depth you have to record the moisture content, report the moisture content which is present in the cement, that you reported standard consistency of the cement, that is from a capital P. Then after standard consistency, I told you have to do the setting time test. So setting time test, actually that is associated with two setting time. So first you have to do initial setting time of the cement. Second you have to do the final setting time of the cement. So so first we have to do the initial setting time of the cement. So setting time means what? So the time when you are adding water into the cement, that time you have to record, and the time at which the cement start losing its plasticity, that time gap is called initial setting time. So first time you have to record at which you are at what instant you are adding water into the cement, and the time you have to record at which the cement start plasticity in the time cap, that is called initial setting time. So time which being measured from the instant of water we are adding, when the instant of the water you are adding, from that time to, you have to measure the time at which the cement start losing plasticity, that is called initial setting time. Okay. So what you have to do, you have to take 500 gram of the cement, and you have to take a water. Already you have measured the standard consistency, how much standard, suppose P the standard consistency of the cement. Then what you have to do, you have to take 500 gram of the cement, then you have to add water, how much, 0.85 times of the standard consistency of the cement. Suppose 100 is coming out to standard consistency of the cement, then 85% of the water you have to add into the cement to measure the initial setting time. Then Beckett apparatus, same thing. Then we have to lower the square needle gently. Then you have to release it quickly. First gently, then you have to release it quickly, and you have to note the time. You have to note the time required by needle to penetrate a depth. You have to record the time. Okay, you have to record when you are releasing the needle. From that time, you have to record the time when the needle will penetrate to a depth of 33 to 35 millimeter from the top of the mold. That time you have to record. So this time is called initial setting time. So for, you have to remember, for ordinary Portland cement, initial setting time is generally, it is reported as 30 minutes. For ordinary Portland cement, initial setting time reported as, it is 30 minutes. Okay. So then we have to go for the final setting time. Final setting time, same, the time, the instant when the water we are adding, the instant when we are adding the water into the cement, to the time when cement completely lose its plasticity and attains the sufficient firmness. Sufficient firmness means when it will become rigid. When become, not completely rigid, but the plasticity will completely, it is about to become rigid. Okay, at the verge of rigid. So the time when you are adding the water to the time when the cement loses is completely plasticity, that time is called final setting time. So same procedure you have to take you have to take 500 gram of the cement, and we have to add the water 0.85 of the standard consistency of the cement. Okay. Then here you have to lower the annular collar. You have to lower the annular collar with a needle, and gently we are releasing this annular collar with needle gently, and we have to release it quickly. So final setting time is the time when the annular collar will not make any impression over the cement mold. Cement mold, it will not, the annular collar will not make any impression, but the needle will show some impression. Needle will show some mark, but the annular collar is a circular kind of thing. It will not show any impression of over the mold, but the needle can show. So for ordinary Portland cement, the final setting time generally it is taken as 10 hours. Okay. For ordinary Portland cement, initial setting time is 30 minutes. Final setting time is 10 hour. How much cement you are taking? 500 gram. What is the water you are adding? That is 0.85 of the standard consistency cement. What is initial setting time? The time at which we are adding the water to the time at which cement just start losing plasticity. What is final setting time? The time when you are adding the water to the time when the cement completely loses its plasticity and it attains the sufficient firmness. That is the thing. What is the size of the vehicle needle? That is how much size? That is 0.1. That is 1 millimeter square. The square needle. Okay. Then soundness test. Soundness is generally, I told you, it is related to the volumetric expansion and volumetric uh, shrinkage and expansion. So we have to measure the soundness of the cement, because if the cement will be more sound, then there will be, when you are using that particular cement in the construction of any structure, if there is some volumetric expansion will occur due to the temperature, then there will be appreciable crack will be formed. Due to the appreciable or due to formation of the crack, the structure will gradually, it will weak, and it will finally, it will collapse. So that's for this, for this, when you are designing any structure, we have to take a cement accordingly. So otherwise, it will, the structure will become fair. So soundness, I told you, soundness is because of the three constituent in the cement. First one is because of the lime, second one is called magnesia, and third one is called sulfur. But the soundness is due to the sulfur. We cannot measure directly or indirectly because there is no test available to measure the soundness due to the sulfur. But for due to the lime and magnesia, we can measure. First, we can measure this soundness due to the lime, soundness due to the lime. So so you can see this is a this total apparatus, this apparatus is called Lee Chatterier's apparatus. This apparatus is called Lee Chatterier's apparatus. So you can see this one is elevation and this one is the top view, or this is called plan. So elevation, you can see this is a mold, okay, mold, and the height in the total height of this mold is 30 millimeter, and total this diameter of this mold is 30 millimeter. So what we are doing, we are taking some amount of the cement, we are taking some amount of cement, and we are adding the 0.78 times of the standard consistency of the water. So initially in initial setting time we are adding the 0.85. So here we are adding 0.78 times of the standard consistency, and we have to make a slurry kind of thing. Okay, we have to make a paste kind of thing, and that cement paste we are filled inside this mold, and we have to cover up the top and bottom by using glass plate, the glass plate. So we have cover top and bottom with glass plate, and we have to immerse the entire assembly inside this water at a temperature of 27 to 32 degrees Celsius for 24 hours. So first what we are doing, we are taking 100 gram of the cement, we are adding 0.78 times of the standard consistency of the cement, and we are making a cement paste, and we are pouring the cement paste inside this cylindrical mold with a cylindrical mold, and finally we are cover up this top and bottom by using glass plate, and we are putting total this setup inside this water at a temperature of 27 to 30 degrees Celsius for 24 hours. Okay, then we have to remove the mold, and we have to note down. You see the top view. We have to. These are called indicators. These are called indicators of the leach Atarius apparatus. After removing from this water for 24 hours, we have to measure the gap in between these two indicators. Okay, we have to measure the gap. Okay, then again what you have to, again you have to immerse this entire assembly for 3 hours at a boiling point. Means the what we have to immerse this entire setup again. So for 3 hours in that water, means boiling water. Boiling water uh, we have to immerse this entire setup. And the water boiling temperature is 100 degrees Celsius. So again what you have to, again you have to take up this entire setup. Again you have to measure the displacement of these two indicators. So we have to finally you have to measure the difference in the reading in both the past. So when you remove, we removed after 24 hours at 27 to 32 degrees Celsius. That time, what is the displacement by these two indicators? We have to record that one. Last, we have to again we have to dip it is into boiling water for 3 hours period. Okay, then what you have to do, then you have to take out, sorry, you have to this setup has to be immersed in a temperature, boiling water temperature for 25 to 30 minutes, and you have to take out, and it is again you have to maintain it for next 3 hours to be cooled off. So then you have to measure the gap in between these two indicators, and the difference in between these two reading, difference in between these two reading, two displacement which you measure by this indicator. This is the distance you have to measure. That should not be more than 10 millimeter for ordinary Portland cement. So that should not be more than 10 millimeter. If that will be more than 10 millimeter, then cement will not be used for the construction purpose. Okay, this is soundness due to lime. Then soundness due to lime and magnesia. Soundness due to lime that can be measured by using Lee Chatterier's apparatus, but the soundness due to lime and magnesia, that is generally measured by using one instrument that is called autoclave. Autoclave. You can see the right side figure. This is called autoclave apparatus. Okay. So this test is sensitive to both lime and magnesia. So what you have to do? Prepare a mold of lean cement size, 25 millimeter cube. We have to prepare, and we have to place this cube inside this autoclave. We have to place this cube inside this autoclave in which steam pressure we are applying, in which we are applying the steam pressure, and which has been increased up to 20 kg per centimeter square, and we have to maintain it for 3 hours. We have to maintain it for 3 hours. What you have to do? We have to prepare a mold. We have to prepare a mold of each 20 meter or 25 millimeter cube. We have to prepare, and that cube we have to place inside this autoclave instrument. We have to increase the pressure of this autoclave. There is a pressure already is there. There is a steam pressure is there. So we have to increase the pressure to 20 kg per centimeter square, and we have to keep it for next 3 hours. Then the mold is removed. Then the mold is removed, and you have to measure the percentage expansion of the mold in each direction. In X, Y, Z, you have to find out what is the percentage of expansion. So in no case the percentage of expansion should not be more than 0.8%. Okay, we should not be more this. We should not be exceed the 0.8% for ordinary Portland cement. So for lime, this should not be more than 10 millimeter. In autoclave, the expansion should not be more than 0.8% for ordinary Portland cement. So next testing of the cement, that is called strength test. In strength test, cement, if you use the cement to make a concrete, cement generally used to make the concrete mortar or like this. So if you make the concrete blocks, so cement has more compressive strength rather than tensile strength. So that's why we are measuring the compressive strength of the cement. So compressive strength, generally it is, you can see that is a called universal testing machine. So in this universal testing machine, we are placing the concrete cubes. Concrete cubes, or concrete cube means the mortar cubes, and which are actually size of 70.5 millimeter or 75 millimeter. Okay. So what first you have to do? We have to take the cement and sand in a proportion 1:3. You have to take. You have to remember this 1:3. Then weight of sand, generally we are taking 550 gram, and weight of the water cement ratio generally taking 0.4. And we have to make a mortar of size 70.5 millimeter or 75 millimeter, and that should be immersed in a water for 7 days curing period. And then we have to take out this mold or that cement cube, and that you have to place inside this universal testing machine. Then automatically here you can see there is a gauge will be there reading. You can directly see the reading at which the cement cube is filling. That reading you have to record from this universal testing machine. So that is called compressive strength of the cube, compressive strength of the cement. So you have to remember, for ordinary Portland cement at 28 days, the cement strength should be 33 Newton per millimeter square. At 7 days, it should be two-third of the. At 7 days, it should be two-third of the strength at 28 days, and 3 days the strength must be 50% of the strength at 28 days. So these are the strength I discussed in today class. So in next class I shall discuss the type of the cement. What are the type of the cement, like rapid hardening cement, low heat cement. Okay, different grade of the cement I will discuss. So I hope it is clear to all of you. So you just share this video along with your friend. If you have any doubt, you just contact me. So thank you. Have a good day.